Do you feel funny, Richard?
No?
Well, I am. I'm feeling funny because I don't know where in the universe we are. Is that funny, Richard?
Let me give you some advice. After this show, go and study your geography. It will make you look smarter. Please remember that.
Whoa. Trying to be smart, eh? If you are so smart, maybe you can tell me where we are. Huh? Tell me. Tell me.
How would I know? I'm just a science robot. Duh. After all, we were searching for Professor Gloop. He must be around here somewhere.
Eh? Did you hear that? That must be him. Let's go. Huh?
Do you see what I see?
I see what you see.
Huh? It's you guys. Welcome to my workshop. Please come in. Make yourselves at home.
Wow, Professor. You look like an ancient warrior in a movie. What are you doing here? Are you making a weapon or something?
No, don't be silly. I'm just molding some metal for a special activity.
What activity? Is there a science fiction festival or something? How come I don't know about it?
No, Kuchen. There's no such festival. We are learning about metals today. That's the activity.
Oh, now I get it. It's just a gimmick, huh? You are so creative, Professor.
Actually, it's just a coincidence. I'm really making something here. Hey, do you know that the two of you were actually born here?
What? Here? In this non-intelligent high-tech place? You must be joking.
Oh, this is my worst nightmare ever.
Oh, stop it, you guys. Most high-tech equipment and modern robotics started in a place like this. You should be proud of it.
Sorry, Professor, but I'm a little busy right now. Oh, by the way, our audience is waiting for you. Shall we get started?
Oh, hi boys and girls. Welcome back to the show. I'm Professor Gloop. Join me and discover the wonderful world of science.
Geez, he's been using that same old opening line for all his shows. Talk about being creative.
Today, we'll be learning about metals. Yes, that hard thing that we see and touch every day.
Hey, did you know that there are 92 elements that can be found naturally on Earth?
Most of the elements can be put into two groups. They are metals and non-metals. Can you think of some things in your lab that are made of metals?
Let me show you some pictures of objects that are made of metals in the lab.
The retort stand is made of metal. The tripod stand is made of metal. The spring balance is made of metals. What else is made of metals? Yes, the calipers are made of metals. The lever balance, the Bunsen burner, and a lot more. Now we will have to learn the properties of metals. But before that, we will do some experiments on their typical properties.
Let's watch the footage of professionals carrying out their experiments.
In this experiment, drawing pins are stuck with grease under rods of different materials: aluminium, iron, and copper. The pins will fall off when the grease gets hot. This shows that all metals are good conductors of heat. In the next experiment, heat up an iron nail. Heat it, and heat it. Does the iron melt? No. So this shows that most metals have high melting points. Okay, let's look at the next experiment. Rub a piece of magnesium ribbon. Metals are often covered in a layer of oxide. But underneath, the metal itself is shiny. This shows that all metals are shiny. Next, hold a plumber wire and pull it hard. See what happens? Well, this shows you that metals are ductile. They can be pulled into shape without using any heat. The next experiment is quite similar. Knock a metal plate with a hammer. Knock it into the shape that you want. This will show that metals are malleable. They can be hammered into shape without cracking. Now, let's look at the properties of non-metals. Poor conductor of electricity except for carbon. Poor conductor of heat. Non-metals have low melting points except for carbon. Diamonds, which are actually made of carbon, have very high melting points. Non-metals are dull. Non-metals are not ductile. They can't be pulled into shape. Non-metals are not malleable.
So, now you know the properties of metals and non-metals. The physical properties of metals can be explained based on their structure and bonding. So, let's see. Here. This is a metal plate. If we look closely into the metal, we can see its atoms. Metals are held together by a sea of electrons. Each atom gives out electrons from its outer shell into the sea of electrons. The electrons can drift about in the metal. These free electrons explain how electricity can pass through metals quickly. You know that most metals are dense? This suggests that their atoms must be packed closely together. The metal atoms are arranged in a regular and closely packed manner to form a giant three-dimensional crystal lattice. The metal atoms are held together by strong metallic bonds. A lot of energy is required to break the many strong metallic bonds in the giant lattices. This explains why metals with these structures have high melting points.
That means if I knock a metal with this hammer, it will not crack, right? Can I give it a try? Meow.
You also need a lot of energy to use that thing. I am surprised to see that you can lift the hammer.
Meow. Here goes.
And he hits my foot. Of course, my foot isn't broken, but it caused me a lot of pain. Ouch!
Hey guys, don't try this at home unless you are a robot or something made of metal like us.
Stop that, guys! We have a job to do. You know, there are a lot of metals, so we put them into different groups. Well, actually, somebody did that a long time ago. It's called the periodic table. This is the periodic table. This is group 1. They are known as alkali metals. This is group 2. They are known as alkaline earth metals. Between group 2 and 3 are what we call the transition metals. Okay, back to group 1, the alkali metals. Metals in this group do not have many uses as metals themselves. Why? Because they are too reactive. They can easily get burned and sometimes explode. They are too dangerous for you to use in experiments.
Since experiments with alkali metals are so dangerous, let's allow the expert to do it for us. Okay? Meow.
They are showing us what happens when sodium reacts with water. Well, the sodium gets so hot that it melts. So, the equation for this reaction is sodium plus water is equal to sodium hydroxide plus hydrogen. Now, what happens when we mix potassium with water? Potassium, when mixed with water, gives out hydrogen gas. The potassium gets so hot that it lights up the hydrogen and it burns. See, I told you, these alkali metals are very reactive and very dangerous. As you experiment more with alkaline metals, you will realize that they get more reactive as we go down the group.
The alkali metals and their compounds are widely used in industry and in everyday life. Let's look at lithium, potassium, and sodium. Lithium is widely used in batteries. Lithium batteries are small and light, but very powerful. Lithium batteries are used in your watch, your mobile phone, your camera, and... Please, can you stop playing with that noisy gadget?
Hey! For your information, this electronic game I'm playing with also uses lithium batteries.
Potassium in the form of potassium nitrate is used as fertilizer. It helps plants grow strong and healthy. Potassium can also be used to make fireworks and explosives.
Homie, that thing is burning! Throw it away! Quick! Meow! Wow!
Huh? Ah!
What about sodium? Sodium is used in street lamps and in nuclear reactors. Sodium in the form of sodium compounds can be added to make food taste better. Just look at any list of ingredients and you will find it labeled as salt. Well, salt is sodium chloride. Salt brings out the flavor in food, but too much of it is bad.
You look hungry, Professor. Take a break. I'll continue since Homie is not here.
Aha! Trying to take my place, eh? Good try, Kuchin. But your little trick with the explosive didn't work. I'm still alive. I'll get you, Kuchin. I'll get you. Okay, guys. Here's the periodic table again, and this is group 2. They are called the alkaline earth metals. The elements from group 2 are beryllium, magnesium, calcium, strontium, and barium. Group 2 are all metals, but they are not as reactive as group 1. The elements in group 2 are quite common, and they can be easily found in rocks or in the ground, like this one I found at the site of the explosion.
You have seen how sodium from group 1 reacts with water. Now, let's compare that with the reaction of magnesium from group 2 in water. Meow.
You see, when we drop magnesium into water, there's no immediate reaction because magnesium is not a reactive metal. But look closely and you will see bubbles of gas given off slowly by the magnesium ribbon. The gas is hydrogen. What happens is that magnesium, when it comes into contact with water, will form magnesium oxide and hydrogen. The equation for the reactions that you just saw is magnesium plus water is equal to magnesium oxide plus hydrogen.
Calcium is another metal from group 2. Now, let's see what happens when we drop calcium into water.
Calcium reacts slowly with water to form calcium hydroxide and hydrogen. The equation for this reaction is similar to that of magnesium when it reacts with water. You have seen what happens when magnesium and calcium react with water. Now, you can conclude that group 2 metals are less reactive than their friends in group 1. Well, like Professor Gloop told you earlier on, the metals become more reactive as you go down the group in the periodic table. We have seen examples of how metals from group 1 and group 2 react with water, and from that we have concluded that group 1 metals and group 2 metals get more reactive as we go down the group. Here's the periodic table again. This time, we are going to learn about metals that lie between group 2 and group 3. These are the transition metals. They have many important uses. Heard of them before? Well, there's copper, chromium, iron, gold, and nickel. Metals in this whole block have similar properties. These are the properties of the transition metals. They are hard, dense, and shiny. They are good conductors of heat and electricity. They are malleable and ductile. Remember what that means? They also have high melting points. Transition metals react very slowly with water. You can only see their physical changes after a few days. Sometimes there is no change at all.
Water causes iron to rust. but has no effect at all on gold. Transition metals are less reactive than Group 1 and Group 2 metals.
Oh, I see. That's why my experiment didn't work on Homie. Shucks, he must be made of transition metals.
Too bad, Kuchen. Too bad. Yes, I'm made of transition metals. Oh, by the way, Kuchen, transition metals and their compounds are very important in industry and in our everyday life. That means, and I am sure you don't want to hear this, that is, I, as a transition metal, am very important.
Back to the transition metals. Iron is a common metal. We make steel from iron and carbon. Here are some examples of how transition metals are used around our homes. Okay, let's see. Water pipes are made of copper. Water tanks are coated with zinc. Radiators are made of stainless steel. Manhole covers are made of cast iron. Light bulbs have tungsten filaments. Door handles are made of brass. Brass is a mixture of an alloy of copper and zinc. White paint has titanium oxide in it. Taps can be plated with chromium. And there is so much more.
Difficult to crack because the atoms are so sleeping. Held together by a sea of electrons, which is metal. Atom gives up, electron can revolve freely. For electricity to pass through quickly. Most metals are found to be dense with the atoms held closely together. Oranged and held a strong metallic bond. Unless of energy can break them. Metals. Some typical properties of metals. A good conductor of electricity. Most metals have a higher melting points. Not dull, but perfect or shiny. Metals are good conductor of heat. The target can be transported through wire. Metals are malleable, difficult to crack because the atoms are closely packed. Held together by a sea of electrons, which is metal. Atom gives up, electron can revolve freely. For electricity to pass through quickly. Most metals are found to be dense with the atoms held closely together. Arranged and held a strong metallic bond. Unless of
Recall. Today, we have learned about metals. We showed you experiments to identify their properties. By knowing the properties, we can see the differences between metals and non-metals. We have also shown you the structure of metals and how bonding takes place. We have also showed you the periodic table, and we learned about group 1 metals, group 2 metals, and transition metals.
So, that's the end of our show for today. See you in the next episode. Bye-bye. Come on, you quarrelsome metals. Let's go home.